Welcome to In 5 Minutes. In this video clip, we will discuss the circuit diagram and working of diode balanced modulator. The balanced modulator is a circuit which is used in the generation of double sideband suppressed carrier signal, which is the second type of AM signal which we use in the transmission and reception. How double sideband suppressed carrier is different from double sideband full carrier is that the carrier signal is not present in the modulated signal. The modulated signal will have only the two sidebands and no carrier signal, and that's the reason it is called double sideband suppressed carrier. Now please remember that you can't first generate double sideband full carrier and then suppress that carrier signal using some very narrow band notch filter and say that now I've got only two sidebands available, so it becomes double sideband suppressed carrier. Why this approach to generate DSB-SC signal will not work is simply because our aim in generation of double sideband suppressed carrier is to improve the power efficiency of the generation. Our aim is to make maximum use of the input power and send maximum amount of the input power into the actual information part of the signal. The information part of the signal is the two sidebands. Now if you're generating DSB-SC first, that means you're already wasting power in generating the full carrier signal, and then if you're removing carrier, you will get DSB-SC signal, the suppressed carrier signal, but it will not help you save the input power from not going into the carrier and use it in the sidebands because you have already wasted the power in the generation of full carrier signal. So I can't generate DSB-SC first and then convert it to DSB-SC. Hence we must have a circuit which directly gives us double sidebands only without any carrier at the output side, and such a circuit is nothing but the balanced modulator. Balanced modulator can use any non-linear device. In this circuit we are using diode as a non-linear device, and hence we are calling it diode balanced modulator. I can also use, in place of diode, I can also use BJT, for example. I can also use junction field effect transistor, JFET, or any other non-linear device. Most famously used non-linear devices are the diodes and the standard transistors, which are BJT or JFET. Let us discuss the working with diodes as non-linear devices. The operation remains exactly same irrespective of which devices we are using. So please remember the main aim of having this circuit with us. The inputs to the circuit will be modulating signal and the carrier signal, and the output will be modulated signal, which will only consist of the two sidebands and no carrier. So we will discuss the working and we will prove that output is suppressed carrier signal with a small mathematical analysis. Let us go through the circuit diagram quickly. On the input side, you can see I'm applying AF. AF stands for audio frequencies, which is my modulating signal. So my modulating signal goes into the circuit from the left hand side input. Now if you observe, the signal goes into the circuit through a center tapped transformer. The primary of the transformer is given the original signal. The secondary of the transformer has a center tap terminal. That means the secondary is divided into two halves. Now the turns ratios will be adjusted in such a way that the input modulating signal, which we are calling V2, we are going to represent it as V2 with this reference polarities plus and minus, will be generated exactly same way across both the halves of the secondary. So across the first half of the secondary we will have V2 generated, and across the second half of the secondary also we will have the same signal V2 generated.